Hello team, in this video we're going to talk about remote storage. So we have seen before that servers have resources, including storage. They run an operating system that mediates access to the resources from applications. So applications go through the operating system when they are accessing resources. And these applications, when they're accessing disk resources, they usually do it through the file system, through the file interface. So we can extend this figure and draw it like this. So applications access disk resources through the file system. So applications access and open files, they write files, and then the file system uses the disk block interface to manage these files. So this is how the interfaces get used in a computer. So storage can be local or remote. Local storage or directly attached storage is storage that is on the same server where it's being used. So in here, this disk is local storage for this server. And local storage is accessed through a bus. In modern computers, the most common bus in use today is PCI Express. A better way of drawing this would be something like this. So we have the CPU and the memory are more closely together, and then the other devices like USB, the network cards and disks, the keyboard, the mouse, they all accessed through a bus, like the PCI Express bus. So this is the common case for local storage. But we can also have remote storage. The main idea behind remote storage is that we're going to have a storage server where we focus on disks. So here I shaded out the CPU because the storage server doesn't need a lot of CPU. It does need a lot of disks. And the storage server will run software that is mostly related to managing disks. So it can have a network file system, it can have a block device manager inside the operating system, and it might have applications that manage storage. And on the other side, we have a compute server. And in this case, this compute server uses remote storage. So it has a CPU, might have a lot of CPU and a lot of memory. It doesn't focus a lot on disk, so it might not even have a disk, or if it has a disk, might be kind of small. And then it will rely on the storage servers to store information. So here we're gonna run virtual machines, for example. So these virtual machines are gonna use CPU and memory that are local to the server, and whenever the virtual machines need to access some file or some storage, they will access the disk resources on the storage server through the network. And we've seen that storage has the file interface and the block interface, and these two interfaces can also be used for remote storage. It just depends on how the storage is made available to other servers in the network. So here we have an application running inside a virtual machine. This application might open a file. When it opens a file, then this file system running on the operating system inside the virtual machine can be a network file system. If it is a network file system, whenever this application accesses the file, the request will go over the network and then reach the network file system on the storage server. And then the storage server will retrieve data from its local disks and then send it over the network, and the file system will send this information to the application. So it's just a file interface that this file system is using to talk with this network file system on the storage server. Another approach would be for the application to open a file, then this file system on the operating system inside the virtual machine is controlling a virtual disk device. So this file system will take the requests that the application sent over the file interface. It will transform these requests into requests for this virtual disk's block interface. So when the virtual machine accesses this virtual disk, the host operating system down here might see that this is a virtual disk and will forward these requests over the network to this block device manager on the storage server. And then the storage server will again retrieve the data from disk and then send this block of data to the compute server, and then the compute server will send this block of data to the virtual device, and then the virtual device will send it to the file system, and then the file system will send this data to the application. So we can have the remote storage being accessed through the block interface or the file interface. It just depends on how the devices are configured. The implementation of remote storage mechanisms has many similarities with the implementation of local storage mechanisms. For example, a network file system will also need to maintain information to be able to retrieve file data from the hard disk. One addition in networked file systems is that they will also have a network protocol that remote servers will use to request information about a file. For example, the remote protocol might specify a given sequence of bytes to be read or written to a file on the remote server. And similarly, remote block storage will also have this network communication protocol and will also maintain information about where each virtual disk block is stored on the physical disks. So here we have an example. We have many virtual disks created on the remote server, and these virtual disks might be used by different virtual machines on different servers in the data center. And then when a request comes in from a virtual disk, this request will access a specific block, either to read that block or to write to that block. And the block storage system will use this mapping to identify on which physical disk and which block on the physical disk a requested block from a virtual disk is stored. And then the physical block will be read or written to depending on the request. So these are some of the implementation details that these mechanisms must implement.